What do overheating engines, blown head gaskets, cracked cylinder heads, and melted pistons all have in common? Well, they usually start with cooling system problems. If you're new to heavy duty or diesel mechanics, the cooling system might look simple radiator, hoses, and coolant, but controlling heat is one of the most critical jobs on a diesel engine. In this video, we're breaking down how heavy duty cooling systems work, why diesel engines generate so much heat, and how each component plays a role in keeping an engine alive. By the end of this video, you'll understand why cooling systems are mission critical and the major components of a heavy duty cooling system, along with how coolant flows through the engine, why engine temperature must be controlled, not too hot and not too cold, and common failure points you might run into in the shop, including an operator complaint that happens all the time in cold weather. And so it's important to keep this system running well, so you don't end up like this guy stuck on the side of the road. Feel for you, buddy. But why are coolant systems so crucial to heavy duty equipment? It's because diesel engines operate under extreme conditions. They have high compression ratios, heavy loads, long run times, and limited airflow at low speeds. But did you know that only about one third of combustion energy becomes useful work? The other two thirds? Well, that simply becomes heat. And if that heat isn't controlled properly, metal expands, oil breaks down, seals can fail, and engine components can warp or crack. The cooling system is like the engine's temperature control system, similar to the cooling system in our own bodies. Just as sweating removes heat from our bodies, coolant does the same thing for an engine. But one big misconception new technicians have is thinking the cooling system's only job is to prevent overheating. In reality, a diesel engine needs to run within a specific temperature range. Again, not too hot and not too cold, just like good old Goldilocks. But what happens if a diesel engine runs too cold? Well, when an engine runs below operating temperature, fuel doesn't atomize properly, combustion efficiency drops, unburned fuel increases, carbon buildup accelerates, and engine oil may stay thicker and not lubricate the moving parts as well as it should. Cold running engines often show white smoke, poor fuel economy, some sludge buildup, and increased internal wear. This is why the thermostat is critical to the cooling system. The thermostat is a control device that regulates the engine's coolant temperature by controlling the flow of coolant into the radiator. When the proper operating temperature is reached, the thermostat will open to allow the coolant to flow through the radiator, where the coolant will give off some of its heat as fresh air passes through the rad fins while driving, or with the help of a radiator fan to help draw air through the rad. The thermostat stays closed to block coolant from entering the radiator before the engine is up to operating temperature. But what happens if a diesel engine runs too hot? Well, excessive heat can cause metal expansion, warped cylinder heads, blown head gaskets, oil breakdown, or cracked cylinder liners or heads. Modern diesel engines also rely on precise temperatures for emissions control, EGR coolers, which are exhaust gas recirculation coolers, which we'll get into in a future video, and after treatment systems. Once temperatures climb out of range, damage can occur very quickly. So what is the ideal operating temperature for coolant? While most heavy-duty diesels are designed to operate roughly between 180 degrees Fahrenheit to 210 degrees Fahrenheit, or 82 degrees Celsius to 99 degrees Celsius. And within this range, fuel burns efficiently, oil flows correctly, component clearances are correct, and emissions systems function properly, along with minimized engine wear. The coolant system's real job isn't to make the engine cold, it's to hold it right in this temperature range, hour after hour under load. But let's look at the cooling system's three main jobs. Number 1, absorb heat from the engine. Number 2, move that heat away from critical engine components. And 3, to release that heat out into the atmosphere. So what exactly is coolant? Well, coolant's a mixture of water and antifreeze, which is typically ethylene glycol or propylene glycol, along with some additives. Water and glycol absorb heat and protect against freezing, boiling, corrosion, and cavitation. The additives help to maintain a proper pH level and can prevent rust, among other things. Most heavy-duty engines use extended life coolant, or ELC, which is designed specifically for diesel applications. Conventional coolants do not have as long of a life cycle as the extended ones, but they perform the same job. Always be sure to use the coolant recommended by the engine manufacturer if you're not sure which type to use. So now that the engine has coolant, how do we move it all around? Enter the water pump. The water pump is the heart of the cooling system, and its job is to circulate coolant through the engine, push coolant to the radiator when the thermostat opens up, and maintain continuous flow. And if the water pump fails, heat becomes trapped, hot spots form, and engine damage happens rapidly. Now earlier we talked about the critical engine components that need to be cooled properly. This includes the engine block and cylinder head passages. Coolant flows through these internal passages called water jackets. These passages surround the cylinders, which helps to cool the combustion chambers. This is where coolant absorbs a lot of the engine's heat. The thermostat we mentioned earlier controls when coolant flows to the radiator. So a cold engine, the thermostat will be closed. With a warm engine, the thermostat will be opened up. A failed thermostat can cause overheating or overcooling, or poor cab heat, and erratic temperature readings. The radiator removes heat from coolant using airflow. Hot coolant enters, air passes through the fins of the radiator, heat transfers out to the atmosphere, and heavy duty radiators are large because diesel engines generate enormous heat loads. The rad fan can also increase the airflow through the radiator when needed, and heavy duty systems may use viscous fan clutches, air controlled fans, or hydraulic fans. They all have the same purpose, and these fans engage more during high temperatures, heavy loads, or low vehicle speeds. Surrounding the engine fan is something called a fan shroud. The shroud ensures the air flows through the radiator and not around it. A missing or damaged shroud can significantly reduce cooling efficiency. Another important component of the cooling system is the radiator cap. The radiator cap maintains system pressure, raises the boiling point of the coolant, and releases excess pressure safely. It also allows for higher pressure to allow the coolant to absorb more heat without boiling. It actually increases the boiling point of the liquid. There's also an expansion tank. As coolant heats up, it expands. The expansion tank stores the excess coolant, which prevents system damage and returns coolant as it cools. Low coolant levels here are often the first warning signs of problems. But let's talk about how coolant actually flows through the engine. The water pump pushes coolant into the engine. Coolant absorbs the heat from the block and head. The coolant then circulates through the engine until it reaches operating temperature, at which point the thermostat opens and coolant flows to the radiator, where heat is released and cooled coolant returns back to the engine. This cycle repeats constantly during operation, and any restriction or leak in the system can disrupt temperature control. Common shop issues you'll find in the cooling system include hose and clamp leaks, which are very common, failed water pumps, plugged radiators, stuck thermostats, air pockets, or cavitation damage. An extremely common issue, especially with newer operators in cold weather, is that there isn't enough heat in the cab. Cooling systems also have heater cores for heating the operator cabs, and these heater cores are essentially miniature radiators that release heat into the cab to help with heating. Let's think of a school bus on an icy cold day. The operator starts the engine and immediately turns on all of the heater fans for the cab, and the coolant temperature is minus 18 degrees Celsius or 0 degrees Fahrenheit. As they start driving, the radiator and all the mini radiators or heater cores in the cab are taking whatever small amount of engine heat has been produced and releasing it in the air. But the problem is the engine itself can't produce enough heat to even get up to operating temperature with all these fans blowing air past the heater cores. In this case, it would be better for the driver to turn off all the heater fans and allow the engine to get up to operating temperature before starting to turn on some of those fans. That way the engine temperature should remain stable, and the air coming out of the blower motors will actually add some heat to the cab. Even though the operator thinks the heating sucks, it's mostly due to a lack of understanding of how the cooling system actually works. So remember that because diesel engines generate massive heat, cooling systems must be working properly to control engine temperature. Engines must not run too hot or too cold, and every component plays a role. Even small issues can cause major failures, so understanding cooling systems is foundational for every heavy-duty technician. Now, if you've ever wondered about the major engine component that controls all the diesel engine's timing, well, watch this video next.